Yesterday in our first lesson in chemistry, we came across this thing called the mole. The mole, again, is just a really, really big number, 6.022 times 10 to the power of 23. And it's just like other numbers, like a dozen and pi and kilogram, they just stand, the word just stands for a number. So you can have a mole of apples or a mole of carrots, but in reality we only use it when we're thinking about electrons and atoms and molecules and compounds, because these are the things that are so small that you have so much of it in a small space. Again, the symbol is N and the unit is mol. We also focused on this thing called molecular mass, because not only do we have atoms, we also have molecules and compounds, and these are when atoms are bound together to form these different substances. And we can work out how much one weighs, or what the mass will be, from this thing called the molecular mass. But how do we calculate that? And just a reminder, we use information that is found in the periodic table, because in the periodic table, the atomic mass, or the mass number, that if we add those together for all the different atoms in the molecule, we get to the molecular mass or molar mass of that compound. So just a couple of reminders. So here is methanol, and if we look at first of all is a carbon. If you look on carbon, it's hard to see, but it's a 12. So the molar mass is 12. Plus we've got 4 hydrogens, which are 1, so we've put 4 there, plus we have 16 for oxygen. So the molar mass of that molecule is 32 grams per mole. Now, molar mass, for example, molar mass of potassium carbonate. We've got 2 lots of potassium. I'm going to start using this periodic table, which is sometimes has decimal places, because that's what we will have in the exams. So 39.1 times 2 plus 12 plus 16 times 3, and if we add this all together on our calculators, we will get to 138.2 grams per mole. Right, so it's a reminder from yesterday. What we're going to do today is extend to that, to now using this molar mass or molecular mass to work out and calculate masses and moles of things. So this is the first of 2 really important formulas to know, to memorize. You don't get given it. So if we want to work out the number of moles of something, we divide the mass of it by the molar mass. And if we write that in abbreviated form, it's N equals little m for mass over big M for molar mass. You can think of it as if it's like a bunk bed and you got to have the small person on top rather than the big person who will break it. Some people prefer it to be written in some sort of triangle form where this middle bit there is divided by, and this is times. So again, just to remind ourselves that N is number of moles in with units mol, little m is mass with units of grams, and big M is molecular mass in grams per mole. So here's some examples. Here we go. First question, how many moles of water are there in 3 grams of water? Here's the molecular mass been given to me, 18 grams per mole. So my formula, write that down first. N equals little m over big M. this here is my little m, this is my big M. So the number of moles of H2O, water, is 3 grams divided by 18 grams per mole. 3 divided by 18 is 0.167, rounding to 3 significant figures, moles. Another example. How many moles of carbon dioxide are there in 64 grams? Again, this is my little m, my mass. Here is my molar mass. To find my number of moles of carbon dioxide, CO2, I divide my mass, 64 grams, divided by my molar mass, and that is 64 divided by 44 is 1.45 moles, again rounding. Okay, so that's calculating number of moles when you have the mass and the molar mass. What can we do? And another way is calculating how much mass we have. So we had little m equals little, n equals little m over big M. And if you like your algebra, we can rearrange to make little m the subject. So that's multiplying both sides by big M. So little m equals n times big M. Or if you had the triangle, that it's, if you block it off, the mass is number of moles times the molar mass. So in this example we have the N of water, 5 moles. I have a question about the mass, it's our question mark, and we've got our molar mass here. So mass H2O equals 5 times 18, which equals 90 grams. Another one, if I've got 0.25 moles of carbon dioxide, what is my mass? So my mass is what I want to find out. And I have my moles is 0.25 mole multiplied by 44 grams per mole. And that equals 11 grams. Okay, so those are the calculations that you're going to be practicing today. You can do these on page 8 of the SciPad or in the ESA guide on page 14, activity 2B, 1, 5, 6, 7, 9, and 10.